Hello friends and my dear students, in this video we will be learning basic concept of IUPAC nomenclature. Means to name an organic compound, either it is a simple compound or it is a complex compound, there are some basic rules by which we name any organic compound. So for naming any compound, for IUPAC naming of any compound, we must know IUPAC name has a maximum of 5 components. How simple the name is, how complicated the name is, it could be divided into a maximum of 5 components. So a IUPAC name is a 5 component system. It is a 5 component system. So any compound will have a maximum of 5 components in its IUPAC name. What are these 5 components? The first component which we think about while naming an organic compound is its word root. The first component that we have to think about is its word root. Word root is to be followed by, after word root what we write is primary suffix. After word root we write primary suffix, and primary suffix is to be followed by secondary suffix. Word root, it is to be followed by primary suffix, and primary suffix is to be followed by secondary suffix. Now before word root what we place is prefix. Before word root what we place is prefix, and prefixes are again of 2 types, primary prefix and secondary prefix. So just before word root we write primary prefix, and before primary prefix we write secondary prefix. So however the simple or complicated the molecule is, the name of the compound could be divided into maximum 5 components, and by keeping these components in mind we can write the correct IUPAC name of any compound. And it is also important that these components should be written in this sequence only. Word root is to be prefixed, means before word root we have to place secondary prefix and primary prefix, and after word root what we have to write is a primary suffix and secondary suffix. Now we'll learn in detail what these component means. What does this component signify in that compound? So word root, first we have thought about word root, so we must know what this word root stands for, what it implies. Word root, it tells about number of carbon atoms in the parent chain. So word root tells about the number of carbon atom in the parent chain. Now what is the parent chain? How to select the parent chain, that I will show you in the upcoming videos. But once we know how to select the parent chain, we can decide the word root. So word root tells about the number of carbon atoms present in the parent chain. Then what is primary suffix? Word root is to be followed by primary suffix. So what is primary suffix? After selecting the parent chain, we have to see that carbon atoms in the parent chain are all single bonded or some double or triple bond is present in the chain. So it tells about the nature of carbon-carbon bond. If in the parent chain all carbon-carbon bond are single bond. All bonds are carbon-carbon single bond, then we use the suffix ane. Just after the word root. If there is some double bond present in the carbon chain, we use the suffix ene. What we use? It is ene just after the word root, and for carbon-carbon triple bond we use the suffix ine. So, primary suffix is to be followed by word root. Word root tells about the number of carbon atoms in the parent chain, and then by selecting the parent chain we can see whether the carbon atoms in the parent chain are all single bonded or some double or triple bond is present. If all single bond is present, then we use the suffix a. If there is some double bond or triple bond, then we use the suffix ene or ine. Now, what does the secondary suffix tells about? This secondary suffix in the compound tells about the functional group present in the compound. It tells about the functional group. Tells about the functional group. Tells about the functional group. In my previous videos in basic understanding of organic chemistry, there is a video about functional group. From where we can know what are functional groups. We know functional groups are atom or set of atoms which decide the chemical behavior of a compound. So, the functional group in a molecule is depicted by a secondary suffix. Then, moving to primary prefix. Primary prefix is used if the compound is cyclic. It is for cyclic compounds. For cyclic compounds. If the compound is cyclic, then only we have to use primary prefix. If the compound is not cyclic, if it is open chain compound, there is no need of using primary prefix. Now, for monocyclic, for one ring, if there is only one ring in the compound, we use the prefix cyclo. Cyclo is used. Where it is used? Just before the word root. By counting the number of carbon in the parent chain, we select the word root, and from that word root, we can see if the compound is cyclic, we use the prefix cyclo just before the word root. For two rings, if there is two rings, and one atom is common between the two rings with one carbon common. If in between the two rings there is one common carbon atom, then the primary prefix spiro is used. If between the two rings one carbon atom is common, then the primary prefix spiro is used. For example, if we have this kind of compound, we can see there are two rings and this one atom is common. For nomenclature of such compound, before the word root we use spiro. And with two or more common carbon, if there is a ring having two or more common carbon, then we use the prefix bicyclo. We use the prefix bicyclo. So if we have this type of compounds, we can see there are two rings and three atoms are common in the two rings. So this compound is called as bicyclo compound, and for such compounds we use the prefix bicyclo. Bicyclo before the word root. We will see in details the nomenclature of cyclic compounds, spirocyclic compounds or bicyclic compound. For now, the primary prefix can be cyclo, spiro or bicyclo. Then comes last component, that is secondary prefix. Now secondary prefix tells about the substituents. Secondary prefix tells about the substituents. Now what are the substituents? How to know that what is the substituent in this particular compound? So when we see the compounds, first of all we have to select the word root by selecting the parent chain. And after we have selected the parent chain, we immediately decide whether it is functional group or not. If functional group is present, it will be depicted by secondary suffix. Other than the parent chain, carbon atoms in the parent chain and the functional group, whatever is present, that is considered as substituent. Anything which is not included in the parent chain or which is not considered as functional group, that all becomes substituent, and substituents are denoted as secondary prefix. So it tells about the substituents. Now, when we write all these components in this sequence, we get a complete IUPAC name of the compound. So, now we'll see what a word root can be. What are the for different number of carbon atoms, what word roots we have. Primary suffix can be a, in or ein, we have discussed over here when it is to be used. Secondary suffixes are different for different functional groups. So we will learn further what the secondary prefixes are used for different functional groups. Primary prefix we have seen, it can be cyclo, bicyclo or spiro, that we have seen over here. And what could be the secondary prefixes for different substituents, that we are going to see. So in these 5 components we have seen what could be primary suffix and what could be primary prefixes used. What is left is we must know what are the different word roots used, what are the different suffixes and secondary suffixes, and what are the different secondary prefixes used. So now here we can see the word root for different number of carbon atoms present in the parent chain. So if you can see, here we have written the number of carbon atoms and here the corresponding word roots. So if there is only one carbon atom in the parent chain, the word root used is meth. For 2 carbon we use eth. For 3 carbon we use prop. For 4 carbon in the parent chain we use but. For 5 carbon we use pent. For 6 carbon we use hex. For 7 carbon atoms in the parent chain we use hept. For 8 carbon in the parent chain we use oct. For 9 carbon atoms we use non, and for 10 carbon atoms we use the word root dec. Now if there are more than 10 carbon atoms, then also we can name their compound, we have the word root for them. We know organic compounds can have very long chain present in the parent chain. So if there are 11 carbon atoms in the parent chain, the word root here used is undec. It is undec. For 12 carbon it is dodec. For 13 carbon it is tridec. If there was 14 carbon, it would be tetradec, pentadex, hexadec, heptadec, nonadec. And then when it comes to 20 carbon, we use icos. We use icos. So there is an alkane with 20 carbon, we say icosane. For 30 carbon, if we have 21 carbon, then anicos. 22 carbon, then we can say doicos. For 23 we can say triicos, and so on. Reaching to 30, it is called as triacot. So if there is an alkane with 30 carbon atoms, we will call it as triacontane. It is not triacot, it is triacont. We call it as triacontane. Then for 31 it is untriacont. Then for 32 it is dotriacont, and so on. Then for 40 we use tetracont, for 50 we use pentacont, for 60 we use hexacont, and so on. And then for 100 carbon atoms we use the word root het. So if there is an alkane with 100 carbon atoms, we will use the word hectane. So these are the word roots. So if you think about the simplest, now we know what is word root and what is primary suffix. Now if you consider a simplest organic compound, we know the simplest organic compound is CH4. CH4. Here we can see there is only one carbon atom, so the word root used here will be meth. And there is no carbon-carbon bond, so it is a saturated compound. We use the primary suffix ane. So this compound is called as methane. This is the simplest organic compound. It is called as methane. So for IUPAC nomenclature, we know there is a maximum 5 components in IUPAC nomenclature, but the minimum, when we talk, the minimum components that an IUPAC name must contain, that is, it must have a 2 component. Meth stands for word root and ane stands for primary suffix. So minimum 2 components is required for naming any compound. So any IUPAC name may contain 2 to 5 components. However simple the name is, however complicated the name is. So word root and primary suffix is making a complete name of this compound. It is methane. So by selecting the parent chain and counting the number of carbon atoms, we will be able to write the word root and As soon as we selected the parent chain, we will be able to decide whether all the carbon-carbon bonds are single, double or triple. Accordingly, we can write whether we have to write word root is to be followed by ane, ene or ine. Now, after word root, we are going to see different secondary prefixes which are used for different substituents. I told you earlier that anything, any group which is not included in the parent chain or which is not considered as the functional group for that compound is considered as substituent, and for substituent we have different prefixes. Halogens, fluorine, chlorine, bromine, iodine, these all are halogens. Halogens are always considered as substituents. If any organic compound has halogen present, the halogens are always considered as substituent, and fluorine is written as fluoro. For chlorine we use chloro, for bromine we use bromo, and for iodine we use iodo. In general, we call halogens as halo. Now, NO2 group or NO group, these are functional groups, but these are some functional groups which are always considered as substituents. So NO2 or NO, whenever present in organic compound, it is always written in the form of prefix. There is no suffix for nitro or nitroso group. So NO2 is called as nitro and NO is called as nitro. So these are always used as prefixes. R. R stands for the carbon chain which is not included in the parent chain. I have not told you yet the rules to decide the parent chain. Now, when you will learn how to decide the parent chain, the carbon chain which is not included in the parent chain, that is designated as R, and it is written as alkyl. I will make a separate video with nomenclature of different alkyl groups. So, any carbon chain which is not included in the parent chain, that is called as alkyl. For example, if we have CH3 group, it is not included in the parent chain. So, this is one carbon chain, so it is called as methyl. It is called as methyl. I will tell you the details how to write the IUPAC naming of the side chain or substituent carbon chain. Then, if some alkyl group is prefixed by oxygen and it is present as substituent, then this group is called as alkoxy group. This OR is called as alkoxy. For example, if somewhere you have OCH3 group, then this will be called as there is one carbon, so it is meth, and this is alkoxy, so it is followed by oxy, so OCH3 group will be called as methoxy group. If it is OCH2CH3, so there OCH2CH3, there is two carbon chain, so the word root there used to be eth, so it will be called as ethoxy. Then pH or phenyl group, from benzene ring when one hydrogen is removed, it becomes C6H5, in short it is called as pH. For this the prefix used is phenyl. These are some groups which are always present as substituent and they are always written in the form of secondary prefix. Other than this, some functional groups may also be written as prefix depending on whether some senior functional group is also present in this compound. Means if there is two or more functional groups present in any compound, then only one functional group will be taken as the main functional group, and for that what we write is suffix. And other functional groups are then considered as substituent and they are to be written as prefix. So for every functional group we have suffix also or prefix also. Depending on in that compound whether it is present as suffix or prefix, we have to write that component in the IUPAC name. We will learn the naming of polyfunctional compounds, and there I will tell you how to decide that in a particular compound having two or more functional groups, how you will decide for which we have to write suffix and for which we have to write prefix. But for functional groups also prefixes can be written depending on what functional groups are present in that compound and how to decide priority which will be written as suffix and prefix. But these are some groups which are always taken as substituents. So far For basic components of IUPAC nomenclature, we have seen what could be the word root depending on the number of carbon atoms in the parent chain, what could be the primary suffix, and what could be the primary prefixes, what could be secondary prefixes. Now we are going to take a look on the secondary suffixes present. Now, depending on the nature of functional group, there are secondary suffixes for each functional group. So, while writing the IUPAC name for a compound having functional group, what is most important is that we must identify the functional group present in that compound. Only when we will identify the functional group, then only we will be able to decide what suffix we have to write. So, we must identify the functional group, and according to the functional group, we will have to decide what suffix we have to write. Each functional group have its structure, and by seeing the structure, we will identify the functional group. Then we will see according to the rules whether that functional group in this particular compound is present as a suffix or as a main functional group or as a substituent, and then we'll decide whether we have to write for that functional group in that compound as a secondary prefix or as a secondary suffix. For example, if you see the first functional group, it is carboxylic acid. The functional group carboxylic acid, how will I identify that carboxylic acid? It is COOH. To a carbon chain, if we have C double bond O, OH attached, then this is called as carboxylic acid. Carboxylic acid, when present in a compound, it can be present as a suffix or as a prefix, means it can be present as a main functional group or as a substituent. We will see later the rules how to decide whether in that compound that functional group is present as a main functional group or as a substituent. After deciding that, if that functional group in that compound is present as main functional group, then we write it as secondary suffix after the word root and primary suffix. We write oic acid, and in some special cases we use the secondary suffix carboxylic acid. So we have to write oic acid or carboxylic acid. When we have to write oic acid and when we have to write carboxylic acid, that is not by our choice. There are defined conditions when we have to use this suffix or when we have to this suffix. In many of these functional group suffixes, I have written two suffixes. So when we have written two suffixes, it is not our choice when we have to use whatever we like to use. There are some fixed conditions. According to those conditions, we will have to decide we have to this one or this one. So, carboxylic acid, when present as main functional group, we will write suffix for it, oic acid, and in some cases carboxylic acid. And in case carboxylic acid is present as substituent, then we will write it as substituent. We will write secondary prefix for it, it is carboxy. Then sulphonic acid. Sulphonic acid is SO3H. S double bond O, OH. This functional group is sulphonic acid. Sulphonic acid, when present as main functional group, it is written as sulphonic acid just after word root and primary suffix. And if acid present as substituent, it is written as sulpho in the form of secondary prefix. Then comes acid anhydride. How we identify acid anhydride? If in a compound we have COO, this group linkage present together, then it is anhydride. And anhydride, for anhydride there is no prefix, it is always written in the form of secondary suffix as oic anhydride or carboxylic anhydride. Then the next we have is ester. Ester is COOR. If to a CO group, OR group is attached, COOR, then it is called as ester. And ester, if in a compound is present as the main functional group, the suffix used is OAT, and in some cases it is carboxylate, OAT or carboxylate. And if ester is present as a substituent, then there can be two different secondary prefixes. You can write it as alkoxy-carbonyl or as alkanoid oxy. When we will see the details of the compounds having functional group, we will learn when to use alkoxy-carbonyl and when to use alkanoid oxy. Means it is not our choice It is not according to our choice we can use any of these prefixes. Now by rules we will have to decide whether we have to this prefix or we have to use this prefix. Moving to next, if the functional group is acid halide COX, if to the carbonyl group CO group halogen is directly attached, then the functional group is acid halide. And acid halide, when present as the main functional group, it is written as oil halide. Oil halide after the word root and primary suffix. Or in some cases it is written as carbonyl halide. Then if we have CONH2 group, this is amide. When CO group is directly attached to NH2 group, this is called as acid amide or simply amide. And when this is present as the main functional group, we use it as secondary suffix and it is called as amide or carboxamide. And if in any case amide group is present as a substituent, then we use the prefix carbamoyl for amides. Now the next we have is cyanide. If we have CN group attached, then it is called as cyanide. And cyanide, when present as the main functional group, it is written as nitrile or in some cases as carbonitrile. And if cyanide in a particular compound is present as a substituent, we write it as prefix cyano. We write it as cyano. Then next we have is aldehyde. C double bond O. When it is on the one side attached with hydrogen and other side when it is attached with carbon chain or hydrogen, this is aldehyde. So CO group is directly attached to hydrogen on one side, it is aldehyde, and aldehyde is present as the main functional group. It is written as suffix and the suffix is al. Just after the word root and primary suffix, we have to write al, and in some special cases we use carbaldehyde. But if aldehyde is present as substituent, we have different prefixes. We can write aldo or formyl or we can use oxo. Now again their usage are not according to our choice. There are conditions when we have to write aldo or formyl and when we have to write oxo. We'll see that in details while naming aldehydes. Then next we have is ketone. Now C double bond O group, this carbonyl group, we have seen this group appears in many functional group. When it is called as ketone, that is very important. When CO group is directly linked with carbon on both sides, on both sides of CO group we have directly carbon atom, then only it is a ketone. If to one side there is a hydrogen, it will become aldehyde. If there is OH group, it becomes acid. If there is a halogen, it becomes acid halide. So identification of ketone, we must be very sure that CO group is directly attached to carbon chain on both sides. Then only it is called as ketone. And ketone, when present as the main functional group, we use a suffix on. This is on. It is not one. It is on. After the word root and primary suffix, we write on. And if it is present as substituent, we can use oxo or keto. Then the next functional group we have is alcohol. OH group is attached to the carbon chain. It is called as alcohol. Alcohol as a main functional group, the suffix is written as ol, ol, and if it is present as substituent, we write the prefix hydroxy. Then if SH is present attached to the carbon chain, then it is thioalcohol. This is thioalcohol, and thioalcohol as a main functional group, we use suffix thiol, and if present as substituent, we use the prefix mercapto. And then comes amine. NH2 group, when attached to a carbon chain, it is called as amine. And amine, F present as the main functional group, we write it in the form of secondary suffix amine, and if it is present as substituent, we write it as amino. Now a very strong question must be coming in your mind when how to decide whether the functional group in that compound is present as a suffix or as a prefix. So for that, it is important to know that if in any compound only one functional group is present, that functional group is always used as suffix. We write always the suffix for them just after the word root and primary suffix. But if it is a polyfunctional compound, means a compound having more than one functional group, then there we have to decide which functional group is to be written as a suffix and which functional groups are to be written as prefix. For that, we must know the order in which I have written this functional group. The order in which I have written this functional group, that is very important. That is the priority order. What we have written first? Initially, I wrote at number 1 carboxylic acid, then sulphonic acid, acid anhydride, ester, acid halide, amide, then cyanide, aldehyde, ketone, then alcohol, thialcohol, and then amine. This sequence is very important. You must remember this sequence. According to this sequence, we'll decide which is to be written as suffix and which is to be written as prefix. Now, when a compound have more than one functional group, then the functional group which comes on top in this table are given more priority than the lower ones. So according to the sequence, we will have to decide which is the senior functional group. The top functional groups are senior and the lower functional groups go on becoming junior. So if there is more than one functional group, senior most functional group is considered as the main functional group, and all other functional groups then are considered as substituents. So the main functional group is written as suffix and the other functional groups present in that compound are written as prefixes, because for that compound they are considered as substituents. So in this way you will be able to decide when to use suffix and when to use prefix for given functional groups. So from this table it is very important, you have to learn to identify the functional group. Only when you will identify the functional group, then only you will be able to write the corresponding suffix or prefix. So most important is that we must identify the functional group present in the given compound. And after identifying the functional group, if there is more than one functional group, we must be able to decide which is senior functional group, so as we may decide for what we have to write suffix and what we have to write in the form of prefix. And then accordingly, we will write the suffixes and prefixes for the corresponding functional groups and we will get the complete IUPAC name. Again, remember one thing, the IUPAC name of a compound consists of 5 components. Most important, the first thing that we see, that we decide while naming a compound is the parent chain. The parent chain, by deciding the parent chain, we will be able to decide the word root. So first what we write is word root, and word root is to be followed by suffixes, and before word root we have to write prefixes. After deciding the parent chain, we will be able to see whether it is all single bonded or some double or triple bond is present. Accordingly, we will decide that primary suffix to be used after word root is ane, ene or ine. And if some functional group is present, accordingly we can write the secondary suffix. What is the secondary suffix? These all, according to the functional group. Then before the word root we have to write prefixes. If the compound is cyclic, then we have to write primary prefix. If the compound is not cyclic, then no need of primary prefix. Just before word root we write secondary suffix if some secondary prefix if some substituent is present. So the sequence in which the name is to be written is, first we write secondary prefix, then primary prefix, then word root, followed by primary suffix and then secondary suffix. These are the basic 5 components. If we use this new rule of naming, we will get the correct IUPAC name of any given compound.